let's talk about relays. Start with some ice cube relays. I like ice cube relays. They're easy to work with. Ice cube relays have two tiers. The base is sort of separated into two tiers so that the screw terminals are easy to identify. The bottom tier has the common and also the normally open. The top tier has the coil and also the normally closed. So on this one, the left side at the bottom, that is the common terminal. We know that it's the common terminal because it's next to the coil. So this is the coil. These are the coil terminals. On the other side we have the normally closed and the normally open on the bottom. So we know that the coil was on the left because here it is wrapped in blue plastic. That is the actual coil, the coil of wire. You can also look at the diagram, and the terminals are numbered. On this side of the relay you can see the contacts, little metal contacts. So let's look at the base a little closer. So this relay is a double pole, double throw. That's why it has two screws on every tier, every level. So here is the common. These two screws are both common terminals. These two screws are the coil. You know that they're the coil because you can see the vertical lines next to them. These two screws on this upper tier are the normally closed, and these two screws on the bottom tier are the normally open. So like I say, the relay is divided into two circuits. So these three screws are one circuit. They work together. So that's terminal number 5 there at the bottom on the left, and that is the common terminal. And the screw on the top, that's going to be the normally closed, and the screw on the bottom, it looks like terminal 3, that's going to be the normally open. So those are all, that's one circuit. That's one half of the relay. So double pole, double throw, that would be a single pole and a double throw of that. You know, it's half of it. Here's the other half of it. The pole, the common, is there on the left at the bottom. What is that? Terminal 8, it looks like. It's kind of hard to see. And then at the top, terminal 2, normally closed, and terminal 4, normally open. So that's the other half of the double pole, double throw relay. That's all one circuit that works together. And then again, these two are the coil. This is a typical diagram for a double pole, double throw ice cube relay. 13 and 14 are the coil. 9 and 12 are the common terminals. 5 and 8 are normally open, and 1 and 4 are normally closed. On this side you have one circuit where 12 is the pole and 4 and 8 are the throws, normally open, normally closed throws. On the other side you have 9 is the pole, 1 and 5 are the throws. If this were a single pole double throw ice cube relay, the diagram would look sort of like this, showing the coil and just one of the circuits. So here is a base socket for a single pole double throw ice cube relay. Here is the pole, or common, and here are the throws, normally open, normally closed. Here is the coil. It has two screws. It has a power and a common, or a positive and a negative. On a single pole double throw ice cube relay, it's nice and skinny, and it's easy to identify the coil because there are going to be two small screws next to each other, where all the other tiers are just going to have one screw. So here is an example of 4 ice cube relays: single pole double throw, double pole double throw, triple pole double throw, and quadruple pole double throw. You're only going to have 2 throws. You can have as many poles as you want, but you're only going to have 2 throws, and you're only going to have 1 coil. The double pole double throw is the only one where it's slightly difficult to identify the coil just right off the bat. So let's look at the single pole double throw. There are the 2 screws right next to each other, so you know for sure that's the coil. And then let's skip the double pole double throw and let's move over to the triple pole double throw, and you see there's a space in between the 2 coil screws. And again, with the quadruple pole double throw, there's a space in between the coil screws. So the coils are really easy to identify, and if you can find the coil, you can find the common right below it, and then you know directly across you're going to have normally open on the bottom tier and normally closed on the top tier. I like to call these peanut relays just for fun, and you should too. This peanut relay has 4 terminals. 2 are the coil and 2 are the contact. It's hard to tell at a glance which is the coil and which is the contact. The coil side is actually soldered on, and the contact side is riveted on. So here is the coil, and here are the contacts. So those 2 contacts are normally open, and when the coil is energized, they will close, and when it is de-energized, they will open. Here is a peanut relay with 5 terminals. They have added normally closed. So here is the coil. You can see they're soldered on. Here is the common terminal, normally open, and here is normally closed. This peanut relay has 6 terminals. Here is the coil. You can see they're soldered on. These 2 contacts are normally open, and when the coil is energized, they will close. These 2 contacts are normally closed, and when the coil is energized, they will open. Here is a relay that we see a lot controlling a fan. A lot of fans are controlled by these kind of relays. Now this is a single pole double throw relay. Here is the coil. These are the coil terminals. This is the common terminal. This is the normally open, and this is the normally closed. Here is a double pole double throw version of the same kind of relay. And here's a better view where you can see the diagram. Down at the bottom, you have the coil terminals. There are 2 separate circuits on this relay. It's a double pole double throw. So the top circuit is there, the bottom circuit is there. These 2 terminals, terminals 1 and terminal 4, are the common terminals. 2 and 5 are normally closed. 3 and 6 are normally open. This is a rib relay. I really like rib relays. They are versatile, easy to read, easy to understand. On one side of the relay you have the switching side, or the load side of the relay, with normally open, normally closed, and common. On the other side you have the coil with, now these are polarity sensitive, so you have a common terminal, designated common terminal. You have a 10 to 30 volt AC or DC terminal for a signal in, low voltage signal in to trigger the relay. And then you also have a 120 volt AC high voltage input. So these relays are very versatile. You can use them, you can feed 120 volt to them to trigger the coil, or anywhere from 10 to 30 AC or DC. So you can use them with universal outputs. If you have an analog output and you want to turn it into a digital output, you can put one of these relays in between. Very handy. They also come in a variety that is enclosed. Both varieties have the LED indicator to let you know when they are energized. The knockout or enclosed style has wires that are color-coded and really easy to memorize. On the load side or switching side, you have yellow for common, orange for normally open, and blue for normally closed. And then the coil side, you have yellow-white for the common, blue-white for the low voltage 10 to 30 volt coil input, and then you have black-white for the 120 volt high voltage input. These relays can also be purchased with a hand-off auto switch or bypass switch included. The switch has 3 positions. Closed means it's kind of like the relay is energized. It means the contacts, the normally open contacts, are connected. Open means that the normally open contacts are disconnected. And auto means that the relay will obey the signal from the coil. These relays come in both knockout mount and track mount style. Contactors are basically just big relays. They can handle more current, but they do the same thing. There's an electromagnetic coil that, when it's energized, it will pull the plunger down. I started with this contactor because it's a good top view, and it's also kind of funny looking. You see these once in a while. You can see it has 2 poles. The top pole has a plunger in the middle, which will go up and down as the coil is energized, so you can see whether the contactor is pulled in or not. And the bottom pole is connected all the time. There is a bar that runs between the 2 terminals, and so they are connected all the time. Then we have the coil terminals on top and bottom. On the bottom you have 2 wires, black and blue, and on the top you have a yellow wire by itself. So 9 times out of 10, when you have 2 wires on one side, that's going to be the common side, and then 1 wire on the other side, that's going to be the signal side. And the reason for that is because the common is shared between lots of devices, and so they give you sort of a courtesy terminal. They give you 2 male spade connectors, so you can put more than 1 wire on them, and you can jump a bunch of contactors or whatever device that you have. You can jump all the commons together. So if you have 2 wires on one side, it's probably the common. A lot of times they'll use the same color wire, like 2 black or 2 white or 2 brown. And then on the other side, you'll have a different color, purple, orange, yellow, something different. And that, more than likely, 9 times out of 10, that's going to be your signal side. So here is a double pole contactor. It's double pole single throw, normally open. Here are the 2 poles. Here is where the coil attaches. On these double pole contactors, the coil connections will be on either side. You still have the 2 plungers in the middle, and you can see them. So you'll be able to tell whether the contactor is engaged or not. Here is a double pole single throw, normally open contactor. It's got a little cover but you can still see the plunger in the middle, like a little button, so you can tell whether it is engaged or not. You should also be able to see if it's not worn off, which it often is, but a lot of times you'll be able to see the coil rating, so you can see there 24 volt AC, and you'll also be able to see a current rating, so you know, an amperage rating and a voltage rating, to be able to tell how much current the contactor can handle. Here is a double pole single throw normally open contactor, and it has a cover on the top, so you can't see the plunger going up and down, but it's nice they give you a little diagram. The coil terminals again are on the sides, and there's that copper coil for the electromagnet down there on the bottom. And here are the high voltage pole terminals. Here is a 3-pole contactor, single throw, normally open, and the pole contacts are on the top. Also, though, the ones on top are labeled L. That's like line in, so typically that's supposed to be incoming. Won't always be hooked up that way, but that's kind of what it means. Is L is incoming, and T on the bottom is supposed to be the outgoing. Now the coil terminals are on top, behind the high voltage terminals. So on a 3-pole contactor, often they are on the top, they are not on the sides. Anytime you work on one of these, you want to be sure you turn the power off, because when you go to stick your needle nose pliers back there to yank on those spade connectors, inevitably you will ground out the high voltage to the low voltage and blow it up. Next we have a motor starter, which is just a large contactor with some thermal overloads built in. You have 3 contacts on the top, all the L or incoming, 3 contacts on the bottom, or the T's, the outgoing. You have the 3 overload, is the thermal overload, so if it pulls too many amps, too much current, the overloads will break contact, and you may have to push this red reset button in order to get the contactor to engage again. And then the coil is here in the middle, and there is a coil rating. You can see it there, 110 volts. Oftentimes with a motor starter, there will be a handoff auto switch on the coil circuit. Hand will apply power to the coil circuit, off will break power to the coil circuit, and auto will wait for the building automation system to apply power to the coil circuit. Here is a newer, sort of a fancy looking contactor, and I put this one in here because it's a slightly different configuration, and it also has auxiliary contacts. So on top we have line in, on bottom we have line out, or the T's. You have an A1 and A2 terminal for the coil. A1 and A2 for coil is very common. But then you also have normally closed contacts, basically auxiliary contacts, and the normally open auxiliary contacts that are all just part of the same contactor. They just give you some extra contacts there if you need more in the circuit. Here is a diagram of a motor starter with a stop and start button. The stop and start button are momentary. The start button is normally open, momentary. The stop button is normally closed, momentary. So when you push them, they spring back. You can see A1 and A2 are the coil. A2 is connected through the reset to line 2. A1 is connected to L1, line 1, through the start button and also the normally open contact 2 and 3. So normally open contact 2 and 3, that is the auxiliary contact of the motor starter. So when the start button is pushed, power is applied to the coil, and the coil will make the normally open contact 2 and 3, and power will continue to go to the coil, keeping the motor starter energized until the stop button is momentarily pressed, breaking the circuit, breaking the power going to the coil of the motor starter. You need to understand this diagram if you're going to be adding relays to the auto circuit of a handoff auto switch. You can also see the high voltage overloads going to that three-phase motor. Another thing I wanted to mention to you is the motor starter coil is obviously something like 240 volt because you're using two hot legs to energize it. Leg 1 is hot, let's just say it's 120 hot, and then leg 2 is also hot. So the two hots meet in the middle, 120 from one side, 120 from the other side, meet in the middle at that coil to energize that 240 volt coil. They do make 277 and these other voltages, so it wouldn't necessarily have to be 240, but that's an easy example to understand. It would also work the same way if it were a 120 volt coil and A2 was connected to neutral.